Exothermic and endothermic. Exothermic reactions release energy to the surroundings, so the temperature rises. Combustion, neutralization, and hand warmers are all exothermic. Endothermic reactions take energy in from the surroundings, so the temperature falls. Thermal decomposition and sports injury packs are endothermic. The clue is in the temperature change. In an exam, if the question says the temperature of the surroundings rose, then the reaction is exothermic. If the temperature fell, it is endothermic, and the temperature change is the giveaway. Reaction profiles. A reaction profile is a graph of energy against the progress of a reaction. For an exothermic reaction, the products are lower than the reactants on the energy axis, and that's because energy has been released. For an endothermic reaction, the products are higher, because energy has been absorbed. Both graphs have a hump in the middle, and that hump is the activation energy. Always label 3 things on a profile: reactants, products, and the activation energy. Lots of students forget the activation energy label and lose an easy mark. Activation energy. Activation energy is the minimum energy needed for a collision between particles to actually result in a reaction. A higher activation energy means a slower reaction. A catalyst speeds the reaction up, not by changing the temperature, but by giving the particles a different pathway with a lower activation energy. The catalyst itself is not used up in the reaction. In an exam, never say a catalyst lowers the temperature or speeds the particles up. The correct phrase is provides an alternative pathway with a lower activation energy. Required practical, temperature change. For the required practical, you measure temperature change for a reaction, like hydrochloric acid plus sodium hydroxide. You use a polystyrene cup because it insulates well, and a lid to reduce heat loss. Record the starting temperature, mix the reactants, then record the maximum or minimum temperature. Plot temperature against the volume of one reactant added, and the peak shows the equivalence point. In an exam, the 2 marking points for why a polystyrene cup are it's a poor conductor, so it reduces heat loss to the surroundings. Saying just it's plastic is not enough. This was your AQA Combined Science Chemistry Paper 1. I hope you found the video useful and good luck in your exams.